Good morning, everyone. Good morning. Hi, and welcome to the first webinar on the WEkEO DIAS this morning. And today we'll be introducing to you the platform and also give you the first insights to the data and tools available and useful for developing applications for renewable energies using Copernicus marine data. We have today, we've lined up, especially for all the participants, a number of experts in the field who will guide you on your journey in the use of the WEkEO DIAS. And I'm very happy to introduce to you. We have today 4 speakers and experts that will be also taking questions from you later on. Before we do that, just wanted to highlight that the chat is normally disabled, but you'll be able to send your questions at the end of the practice sessions. I will be taking questions from you. So don't worry, all the questions will be also addressed. And we're gonna kick off with the presentations of our speakers today. So we have Mr. Stefan Orevich, who is involved in the WEkEO user support as a senior advisor. He has been involved in Copernicus user uptake activities for more than 15 years. So we'll be very glad to have his expertise today with us, and is an expert in Copernicus market development and user engagement. Then we have Mr. Fabrice Messal, who is training and educational manager for Marketer Ocean International. After 6 years developing partnerships and projects in the frame of the Marketer Ocean outreach activities, he's currently in charge of the training activities for the Copernicus Marine Environment Monitoring Services. As you might know, Fabrice has a background in science and applications, as well numerical imaginary, and has professional experience in visualization of software development and scientific mediation. Next, we're going to have a presentation by Aurélien Mur, who works at the Mercator Ocean International as well as a user learning officer. And today, together with Fabrice, in fact, he supports marine user engagement and training with a particular focus on Copernicus data development. He's an expert on many Copernicus and specific marine applications as well. We have a very extensive presentation on that. And finally, with us in the question and answer section, we're going to have Amin El Amrani, who's a satellite imaginary expert, also today with us. And he's a WEkEO user support expert specialized in technical issues. He deals daily with users' issues as well. Right, so today's agenda, without further ado, we've got allocated 2 hours in total with a little break of 10 minutes. And I would like to, I could give already the floor to Mr. Stefan Orevich, who's going to talk about possibilities offered by the Copernicus for renewable energy applications. And then we're going to move on to Mr. Fabrice Messal, who will talk on Copernicus marine service and data provided for the marine renewable energy sector, as well as give us already the practical session information and the introduction as well. In this first part, then we're going to break for 10 minutes, and we're going to move on with more practical live demo by Aurélien and questions today. Again, I repeat, we'll be taking all your questions, so don't worry. All the questions will be replied to you. And without further ado, let's kick off. And I'll give the floor to Monsieur Stefan Orevich, please.
Good morning to those who are in Europe. Good afternoon or good evening to some others. We usually have users connected from very different places around the world. We're happy to be with you today to discuss the applications related to marine renewable energy in WEkEO. And before we start dwelling into the technical details, I will give you an overall introduction about WEkEO. If that introduction will be a synthetic, because we have already quite a number, I think 15 previous webinars that are recorded and available on our YouTube channel. So no need to go into too many details. So let me try to share my screen, if I may. So this should work. Oh, that. Okay, so as said by Joanna, I am a senior expert at the WEkEO user support, and I will walk you through the main characteristics of WEkEO. So what is WEkEO? WEkEO is one of the 5 data and information access services funded by the European Commission. It's a special, we call them DIASs. So it's a special DIAS because it is implemented by 4 of the key partners of the European Commission in the implementation of Copernicus. The Mercator Océan, who's our host today, Mercator Océan International, who is responsible for producing and making available the marine service, by the European Environment Agency, who's responsible for the land monitoring service, by ECMWF, European Center for Medium Range Weather Forecasts, which is responsible for the climate change service and the atmosphere monitoring service, and last but not least, by the European Organization for the Exploitation of Meteorological Satellites, EUMETSAT, who is operating and providing the data access to several of the Sentinel satellites of Copernicus. Industry is heavily involved. Most of the work is outsourced to private companies, which is also important because it contributes to the development of a sustainable Earth observation sector in Europe. One of the first characteristics of WEkEO is its distributed infrastructure. Unlike other DIASs who basically copy the data into their own cloud infrastructure, in this particular case, there's no duplication of the data. And there's no duplication of the data because the data, basically the data custodians, the data producers, the data owners are the partners of WEkEO, so they don't need to duplicate their own data. This has 2 consequences. Well, 3. The first one is you always get the most up-to-date data because there is no need to copy it, it's there. So as soon as a new product, a new image is available, you can find it in the catalog of WEkEO. Second, and these days that matters very much, we believe WEkEO is the DIAS with the lowest carbon footprint because by definition, we don't have to add additional cloud infrastructure, which are consuming a lot of energy. We're just using the data where it currently and regularly sits. Finally, using WEkEO, you have the guarantee to always have the latest product offering from Copernicus, because just to take one example, whenever, for instance, the land monitoring service releases a new product, the product is usually developed on WEkEO and therefore immediately available on the platform. So that's also a guarantee long term. Another point is because the owners, the shareholders of WEkEO are institutions, and because the funding for the platform has been agreed with the European Commission for the next 7 years, you have a guarantee that you're not dealing with some commercial actor that might decide to discontinue the service because it's not making money or it's out of its strategic focus. There is a commitment, very firm, and it's enshrined in the agreements between the European Commission and the various actors of WEkEO. You have a guarantee that whatever you start developing on WEkEO will still be available in 7 years, and obviously even over and above that time limit. What's on WEkEO? WEkEO is first and foremost a single access point to the entire catalog of the Copernicus data, so satellite data, and information, all the products and data sets developed and produced and made available by the various Copernicus services. And I'm saying not all of the data, some of it we're still in the process of ingesting, plus because of data formats, etc. Some of the data might not yet be in the catalog, but you could always copy it into your Jupyter notebooks or into your virtual environment in the cloud and process it there. Second, the system is completely cloud-based, so no need to download anything but the final result of your work. So sometimes, I mean, a Sentinel-1 tile can, so radar, synthetic aperture radar, can weigh over 1 gigabyte. Imagine if you have to download a large area. In this case, you can do everything in the cloud. Last but not least, one of the very unique features of WEkEO is its user support service. Because behind WEkEO, you have the institutions which produce or distribute the data of Copernicus. You have, by definition, the best experts in the characteristics of the data, the format of the data, the uses of the data, and that user support is available with, I'll come back to it, various levels of expertise and depth to answer basically any question you would have about both the WEkEO platform, its offering, its peculiarities, etc., but also on the data itself and on the applications that can be developed with that data. So in summary, our main assets are, we don't copy, it's the original, it's available immediately as soon as it's injected into the Copernicus infrastructure. The user support and this harmonized data access that allows you with just one API or one routine, one program, whatever, to immediately access the data without waiting for it to become available by cut and paste, basically, which is the case in the other DSs. WEkEO addresses all kinds of users, from institutions to the private sector, scientists. We have a lot of users who are scientists, and the civil society, because and we'll come back to it, you have this very nice viewer. You don't need to have a PhD in remote sensing or in information technologies to browse through the data and discover the many data sets that are available in the platform. The catalog. Well, the catalog, you basically have all the Sentinel data, you have all the main products from the various services, and you can access the data. Once you register, you can process the data, you can download the data, etc. And you have the possibility to have a direct dialogue with the user support service. So, as I said, all the satellite information and Sentinel-6 will be coming soon. You have the services from the four main services in terms of development of data sets that can be reused for applications. You have the IT infrastructure, the cloud, you have the tools, the Jupyter notebooks, the virtual machines, the GPUs. You have a lot of online resources, wikis, frequently asked questions, training material, etc. And you have a marketplace in which you can look, well, companies, startups, entrepreneurs can showcase the developments that they make with WEkEO. And this is also a source of ideas with people looking at developing novel and innovative applications of Copernicus data. As you can see from this latest screenshot, there are currently 309 data sets available, and they range from marine currents to land use, to NO2 forecasts of air pollution, all the way to time series of information from the Copernicus Climate Change Service. You have this absolutely awesome viewer. You get some examples that can be used to visualize radar, synthetic aperture radar data from Sentinel-1, optical data from Sentinel-2. Here you can see that ship that got stuck in the Suez Canal a while ago. You can see the Copernicus marine data. You can see Sentinel-2 data. And it's very versatile and it's very easy to use. I mean, I don't have a technical background, I have a political science background, and I am using this viewer to discover Copernicus data. The user support, it's operated all working days, on regular opening hours, with 2 levels. A level 1 that answers, I would say, easy questions, and a level 2 that builds on senior experts from EUMETSAT, ECMWF, Mercator, or specialized contractors. And you have, as I said earlier, a wealth of support materials in the form of FAQs, a YouTube channel with training sessions, webinars, and we're also quite active on social media, trying to not to just do publicity about the beautiful things we do, but also to show use cases, etc. In the user support, you have, as you can see here, quite a lot of resources, and we're continuously updating that knowledge base in order to offer the most up-to-date user support. We have, as today, our series of webinars, with quite a number of them already available online on many different thematics. All the Jupyter notebooks that have been developed for the webinars and training sessions are available in the cloud on our infrastructure. And we have already 38 training videos that you can look into. We're on Facebook and Twitter, so follow us if you're interested. We have a dedicated page to request support. And we have rather stringent obligations in terms of time to respond. And this is closely monitored by founding partners of WEkEO. So you can expect to get an answer rather rapidly and quite an in-depth. And modestly for the user support colleagues, the level of satisfaction displayed by our users is quite high. Pricing. You have quite a lot of things in WEkEO that you can do for free. Well, obviously, you can register for free. You can search for data. You can discover data, visualize data, and download it. That's completely free. You can also promote whatever you're doing with WEkEO for free. The only thing that you have to pay for is computer power, tools, storage, etc., which is quite logical. That's a pay-per-use, and there's quite a wealth of different schemes and plans with different rates. So the support, discovery, visualization is free. The download and playing with Jupyter notebooks, this can also be done for free. But as soon as you need virtual machines, tools, GPUs, etc., then you have to pay. There's a Jupyter Lab where you have quite a number of Jupyter notebooks that you can play with, and is a very good tool for training. Different pricing plans, as I said. Once you go into the advanced, the prices range from 125 euros per month to several thousands, but these several thousands are obviously for industrial development of companies, startups, etc., that would want to develop an app that functions with data processed onto the platform. You will also note that there are rather generous trial periods, 5 months for the lighter plan to 1 month for the more complex or more rich ones. And there is quite a flexibility in extending those trial periods for scientific applications or applications that show a high potential and are highly innovative. Because again, this was not built to make money. This was built as part of the European Commission's drive to ensure that the Copernicus data and information is used to the widest possible extent. There is quite a lot of flexibility, so don't hesitate to contact user support if you would want an extension of any trial period. So join the WEkEO community on our web portal, on Twitter. Don't hesitate to contact our support office. We are really very service oriented, and we never hesitate to go the extra mile. That's it for my high level introduction. And obviously, if you have specific questions, we'll be glad to answer them in the Q&A session after the technical presentations. Thank you for your attention.
Thank you very much, Stefan. Thank you for that broad overview and an introduction to our session today. And without further ado, as Stefan has mentioned already, we'll be taking your questions later on at the end of the session. So we're really looking forward to it. We're gonna move on to our next speaker, Fabrice. Messal, with a lot of useful information for all of you. So get ready, get to your pencils ready to jot down all the information. Thank you. Fabrice, the floor is yours. Yeah.
Thank you. Hello, everyone. I'm very pleased to be here with you today. My presentation will talk about renewable energy I prefer to broaden the scope of my presentation and not focus only on the marine renewable energy, because we can touch many domains with the WEkEO data and the WEkEO platform. So let's share my screen with my presentation. Okay, can you see my screen?
Yes, we can see it very well. Thank you.
Okay, thank you, Joanna. So let's start to talk about renewable energy. So as I said, I prefer to have this broad presentation on renewable energy sources and how we can support your activities. So there is the hydroelectric power energy, the biomass energy, geothermal energy, wave energy, tidal energy, solar energy, wind energy, and the products provided by the WEkEO platform can help you in all this domain to different sort of studies or your exploitation. Because what is this source of energy have in common? This is the lifetime project. And during all the lifetime of the project of a renewable energy site, you have the same needs on to build report, to build assessment on your project. First, there is the site characterization. Okay, you have to manage the choice of the site for your project. You need to make production efficiency estimation of your project. You need to assess the environmental impact to provide proofs that your project is sustainable and relevant and keep the environment clean. Then you have the part of the building infrastructure. You need to take care of the people who are working on your platform. For example, when you develop an offshore platform at sea, you need to take care of all the workers at sea and the material. So you need a lot of information about the state of the ocean, for example. About the exploitation during the lifetime, this part of the lifetime of your project, you need to make some forecast about the production of your site. Take care again of the safety of the people who are working on your station. You have to provide regular environmental impact of your site. You need to manage all the maintenance efforts. So for all of this, again, you need a lot of information about your environment. And at the end, the last step, this is a dismantling of your site. Again, you need to provide a lot of information concerning the environmental status, for example. The WEkEO products are available directly on the website. You can download it. You can directly use the data. So you can use the product as direct information. Okay, you need forecast on this part of the world. You need long time series to evaluate the potential sites. Okay, you can directly download the data, play with it, and directly make your map, etc. But you can also use the product as an input data for your own operational system. Okay, you have developed, or you ask a company to develop a forecast or predictive model on your area of interest. You can use this data as boundary conditions for your downscaling model or long-term prediction model. You can use the long-time series data in the past in your predictive model with machine learning and intelligence artificial. So there is different way to use the product. It can be the direct information or an input data for added value product for your operational system. So I will go through some renewable energy sources and give you example of products available for each sources. This is not an exhaustive list. Let's start with, for example, hydroelectric energy. And when you are in the phase of the exploitation of your hydroelectric site.
Sorry, Fabrice.
Yes?
Sorry, Fabrice. I'm not know if you, is it on purpose that you're not sharing your screen? We're not seeing your screen since the beginning of your presentation. I thought.
Oh, really?
Oh,
Yes.
I could see it.
I can't. I have, okay. Oh, sorry. I had the wrong setting. Apologies. Apologies.
Okay.
I could see it, and everybody, we'll check again with another speaker, but I can see it very well.
Okay, thank you. I see the
believe that
comment on the
attendees-
discussion. Okay.
I believe our attendees can see it as well. Absolutely. Yes.
Okay.
Sorry. I had
No problem.
Fabrice full screen and I was worried. Sorry.
So let's go back to, okay. So during the exploitation phase of an hydroelectric station, perhaps you would like to assess the snow-covered area, so monitor the snow, have information about the river's discharge. So you can have access to this product, for example, Sentinel-2 with optical product, Sentinel-1 with radar product to monitor the wet snow. The Copernicus land monitoring service provide data in real time on snow and ice products. There is a seasonal forecast of river discharge. You have a lot of indicators provided by the Copernicus climate change service. And so, okay, there is some of products you might be interested to in the exploitation phase of your hydroelectric site. And this is an example of the viewer with an image of Sentinel-2 and a radar image from Sentinel-1. About the wind energy sites, during the site characterization, perhaps you want to check, for example, if your site you choose is not on a protected area, because you will have to provide a lot of environmental impact. So you can check this on the current land cover product and the high resolution layer of Natura 2000. You can have also access to the Sentinel-2 optical product with the example of scene classification. Then you want to assess the climate environment, and you can use the reanalysis to assess the potential production with the wind, thanks to ERA5 product. During the exploitation phase, you can have access to dust and aerosol monitoring and forecasting information with Sentinel 5P, Sentinel-3 and the air quality forecast from the Copernicus atmospheric monitoring service. because we know that, for example, for wind turbine, it can be a problem if there is a lot of dust on the material. And then let's move to the solar energy. This is similar for the site characterization phase. The similar product you can use to check again the land changes and uses to plan installations, to assess the climate environment, and you can assess the amount of solar radiation available. You have access to solar radiation time series with historical values, and again during the exploitation phase, it can be very interesting to have access to dust and aerosol monitoring and forecasting, also with ozone, the variable with the ozone variable available on certain products because it can affect the solar radiation. And finally, on the marine renewable energy, during the site characterization for the impact studies and production prediction, you will have access to regional analysis or multi-year physical wave product to assess the potential impact of the current and the impact of the waves on the structures. And also you can have access to wind observations. During the infrastructure, the building of the infrastructure phase, for the safety of the sea workers, you have access to analysis and forecast of the global and regional seas with a physical variable like currents and the waves variable. And during the exploitation phase, you can check all your site thanks to Sentinel-1 radar and assess the environmental impact with Sentinel-3 all-seer observation with information on the phosphor, for example, for the chlorophyll, etc. So the health of the environment around your site. After this presentation, I will move to a short demo and practical session. So I will give you a quick overview of an existing Jupyter notebook available on the WEkEO platform. This is a notebook on wave products using our IPA HDA. And then Aurélien will give you a tutorial on how to use WEkEO data with a GIS tool on QGIS to assess the wind speed and direction for a project, for example, for an offshore wind farm, and the assessment of an extreme event consequence. Stefan already shared this information, but there is a lot of videos available on our WEkEO YouTube channel. Don't hesitate to have a look. And we have a powerful user support, so don't hesitate to contact them. And now I will dive directly on the website and the viewer to show you some products, snow ice products, Natura 2000, solar radiation, Sentinel-1 and 2, and wave products and bio products. So now let's dive in the website. So now this is the homepage of the website. So you can directly access data clicking here. So this is the viewer, and you can display layers related to the products, and you can see on the left side of this screen the list of the layers are already open before the webinar. If you want to add some layers, you have just to click here on the plus icon, and you can filter all the products available, or by service, by platform, area, tags, some tags directly linked to the variables you want to check. And so, for example, I don't know if I already charged this item. Snow, for example. Yes, I will have information on the snow and ice monitoring. So this is a product available here. So you can add to map directly, and you can choose which variable you want to display. So I already download this product. This is a fractional snow cover. Is here. Now with this icon, I can show the layer or hide the layer. Let's show the layer. Okay, I have to zoom to view the layer. So let's zoom on Europe. And now I can change the date with the time, the timeline here. So there is perhaps no data available at this moment. So I can play with baseline if I want to have information. I have to zoom again. Okay, you can put some time to load. Let's move to another, for example, Sentinel-2 color. So this is the true color variable from the Sentinel-2 product. So you can see the detail. I can check if there is snow on the region. I can change the date. Okay, you see it's very simple to add some layer and to visualize some layer. This is another layer on Sentinel-1. This is radar imagery. For the same date, I can display the two layers at the same time. And if I want, I can play now with the transparency of the layer to check what's behind. Okay. Okay, and this is the first layer, fractional snow cover. Here you can see. I will hide the other layer. I will put the base map back. Okay, and now you see the first variable, fractional snow cover. So this is the kind of product you can have on the directly on the viewer. I will show you after that how to download the data. For some of the product, you cannot display the product directly on the map. This is the case for the CAMS solar radiation time series, for example. But let's check how to download the data directly. So I will click on this button, subset and download. I have to be registered on the WEkEO website to be able to download the data. So I have a WEkEO account. I sign in. And now I will be able to make my subset and to download the data. So let's check if I can have some information on my zone, for example. Let's keep this date and okay, 2002 January, for example. Okay, include free conditions only. I would like 1 month time step, true solar time. I want an HCDF file. For the latitude, okay, let's play with the viewer. I will take this position. So enter the latitude and the longitude. The altitude, oh, I don't know the altitude. Let's put 1000 meters, okay? And now I can request directly this data. So the request now is on my job list. So let's check my job list. So the CAM solar radiation time series job is running. So I will check after the demonstration if the job is complete. And there is an example of a complete job here. Once it's done, you can directly download the data, show the results, and you can directly download the NetCDF. So I already download this completed job on my computer, and I can show you the results using, for example, a free software available on internet called Panoply. So I open Panoply. Okay. Okay. Hop. Solar radiation, okay. Okay, oops, sorry. I will try to, I don't know how to share the interface of Panoply. Yes, it's working. Okay, it's working. So I take directly, open file, my CAMS solar radiation file. I open it on Panoply, and then I can choose the data. And when I want to create plot, so this is just an information, a time series of the evolution on one position. So I have to choose line plot using time for the horizontal axis, and then I can create directly the plot. I have directly the information of the solar radiation for this specific location. Okay, so you see it's very simple. I made this this demo live with you. Okay, the job is still running. Can go back on the layer. So we see the solar radiation. We already see the Sentinel 1 and 2. We can dive now on marine products and see, for example, sea surface wave significance. So I can zoom out to let's discover the complete scene. So now I can choose to select my area of interest. For example, here, I want to have information on the sea, the state of the ocean at this on this area, and I can again make my subset on this area. So I will not again download the NetCDF file, but I will show you how to extract the request, the HDA request to use on a Python script, for example, a Jupyter notebook. So I define my area of interest. I can copy directly on the bounding box like this. I can choose the start date and end date for my studies. So let's put the 1st of March to the 1st of April. Now I can request data like I did for the solar radiation and choose to have directly the NetCDF. Okay, this or okay, sorry. Yes, We are in 2020. Let's move to this date. Choose an end date after, okay. No, it will not work. So let's start with the 1st January 2022 to the 1st of April 2022. Okay, that is correct. Now I can request the data or a new request again. Okay, 1st March 2022, 1st January 2022 to the 1st March, 1st April 2022, for example. And now I can show the API request and start from here. It's very simple. You have just to copy this part to put directly on your Jupyter notebook or your Python script. Okay, you have the information about your area of interest, the dates you want, and the variable you want to download directly on your file. So now let's move on the Jupyter Hub. This is resource available on your WEkEO platform, and you have just to be registered to have access to this. This is part of the free access of the WEkEO offer. So now I move to the dashboard. Okay, so this is my dashboard with my profile. I have access to lots of features, the virtual machine, the WEkO drive, etc. And there is a link to the Jupyter Hub. So I will click on the Jupyter Hub. So for those who are not familiar with the Jupyter Hub, this is a web-based environment, very useful for training activities, for example, because you can share lots of piece of codes in Python, for example, or Julia or R, and it allows trainers to share information through narrative text and codes. So you can merge narrative text and codes in the same file. There is a lot of Jupyter Notebook already available on the public folder. There is a list here of different folders: atmosphere, climate, land, ocean, machine learning. So if you click, you can browse, and you will find Jupyter Notebooks, different Jupyter Notebooks on different topic. And this is my own workspace, my own directory. There is a folder on renewable energy, and my colleague David Bazin worked a lot to provide this information to you today. So this is a Jupyter Notebook dedicated on wave products and related to South America, but it can be launched or can be adapted on the region you want, in fact, because as you see in the HGA request, you can choose your area of interest, and you have just to copy paste your HGA request directly on the Jupyter Notebook. And I don't know if we will have time to run through all the Jupyter Notebook, but just to show you the beginning. So I will go step by step, cell by cell into the Jupyter Notebook to show you how it works. So let's move. So you have a table of content to explain you the different steps of the exercise. You have just to press the play button to run each cell. And when you have this kind of cell here with a piece of code, you have into the bracket a star, meaning that the cell is running. And when you have a number, the cell is completed. Okay, so let's move. So I have to import some libraries. I have to load my credentials. So this is an introduction about the exercise we propose. Okay, let's move on. Okay, so we will use the global ocean waves analysis and forecast products. So this is a direct link to the product sheet directly import on your Jupyter notebook. Now I want to download the data. So I will use the harmonized data access, HDA, okay? So there is a video available on our WEkEO YouTube channel to understand how it works. So I need some info, some installation. Okay, I run, okay. And now, okay. And now this is the cell. You have to copy paste your own HDA query, okay? This is the zone I defined before, but as I showed before on the viewer, you can directly choose your own area of interest, show the API request, copy the API request, and you copy paste here the API request. And you can continue to run the Jupyter notebook, and you will have the maps on your own region. Okay, so it's very simple. So in this Jupyter notebook, we have to download the data. So this cell is running the job to have the NetCDF file. Now I download the data. Okay, so perhaps it will take time to download the data, but I've already downloaded in my folder data, so I can continue to run the Jupyter notebook. Just to show you at the moment. Okay, you have to download the data here. But you will see we will make some maps on wave products, and we can create animation. And at the end of the Jupyter notebook, you will be able to provide wave rows to have an estimation of the potential of your wave energy site at your own location. Okay. So I think it will take too much time to cover the entire notebook. So Joanna, don't hesitate to interrupt me.
Yes, I've been just watching the time, but it's so fascinating. You're giving us so much information. I didn't want to stop you. You can go ahead for a few more minutes. We're still in time, you know. So I think we should. Yes, go. You know, we are at 11:23 right now. Just to remind you. Yes.
Okay, just to see some maps. So okay, we succeeded to download the file, and now I'm going to plot the maps. So I import all the modules I need to make this. Then I continue. As you see, I didn't run this cell, so let's continue. Okay. So I make some operation to prepare some functions, and then I will access the data. So just check what is inside my NetCDF file. So I have information about the grid of my file with latitude, longitude, and time, and I have the different variable with the wave height. Okay. Let's check the variables. Okay, and the coordinates. Okay, everything seems fine, so I can continue. Now I will prepare my configuration to to plot the map. Okay, mean value. I will not put mean value or max value directly on my map. I check again my dimensions. That's fine. And now I can generate the map. Okay. So now this piece of code will generate all the map for each day. And I will put not only each day, but each 6 hours, I will have a map on the wave height. Okay. All the map will be saved in my out folder. And you will see we will be able to display an animation. So let's go through this. Okay, I run all the cell waiting for choose one. And if you want to check with me, let's go to the out folder to see the first files. Okay. So this is the results of the first part of this Jupyter notebook. You will be able to create this kind of map and to create this animation. Okay, so this Jupyter notebook is not yet available on the public folder, but we hope by the end of this week or the beginning of next week, you will be able to access this Jupyter notebook and to play with it, to change your area of interest, change the data, change the value, the variable, and play with it. Okay. And this is the animation directly on the Jupyter notebook. Okay, I will not go through the second exercise. I want to let some suspense for you to play with it, and don't hesitate to contact the user support if you need some help. But as you see, it's very easy. This is a great tool to share with you codes. Don't hesitate to take this piece of code and build your own program. Okay.
Thank you, and thank you for leaving us with a bit of a suspense as well, Fabrice. Correct? Yes, Stefan.
Before we go on the coffee break, as there are only 2 questions, I suggest that we take them now.
Oh, splendid.
They're general and they're not, why wait another close to an hour to answer them? I'll take the first one, which is from Gianluigi Renzi. Could we forget, between brackets, all the other hubs, I guess DIASes, just WEkEO? That's a very good question. I would say if your interest is in Copernicus data, the answer is definitely yes. WEkEO, in terms of breadth of catalog, in terms of up-to-dateness, I don't know if the expression exists in English, of the data, you won't find anything better. And it's all in one place. And again, the fact that you're working with the custodians, producers of the data is the best guarantee you can get. There are differences, obviously, between the product offering of the various DIASes. Other DIASes has things that WEkEO doesn't have yet, as other things that WEkEO does not intend to deploy. Examples are some DIASes have VHR from Airbus, from Maxar, from Planet, etc. WEkEO is working on, is looking into the possibility of also working with VHR providers. Some have data from other contributing missions, from NASA, from JAXA, etc., which is, we're really focused on Copernicus. Although we might add some stuff. There's other differences. For instance, several DIASes have anonymized mobile phone locations, which enable to develop some particular applications. But again, if you're looking for Copernicus open data, free data. WEkEO is the DS to use, because these features that I'm mentioning from other DSs, these are features that are not free, that you need to pay for. The other question I would leave to Fabrice. It is from Gregor Bierle. Could you use Snap for this product type as well, or is Panoply better suited for displaying time series? You're mute, Fabrice.
Sorry. I could have used Snap to do this, to display the data, but I choose Panoply because it is a very simple tool. It is free, and Snap is very powerful. If you want to play with Sentinel data, I recommend to use Snap, but you need some skills to use Snap, because it can be very complicated to perform and to have access to all the features proposed by Snap.
Okay, so we're going to take a short break. Before we take a break, I just want to make one remark. We're really thrilled by the number of participants to this webinar, and thrilled in particular by the presence of so many people outside Europe. There's quite a lot of participants from Africa. In particular, I see that Vivian Mehta from Locate IT in Kenya is there. Locate IT is the company, is a pioneering SME founded by my late friend Eric Kamala. I'm really happy to see her attending, and I think it's great. And one of the advantages of the DS obviously is you can rather easily get rid of the obstacles of low connectivity or unavailable connectivity. I've seen people using WEkEO to make demos using their phone, tethering from their phone in 4G in the middle of nowhere. It works. It doesn't create any major operational problem. So DSs are also partly for Earth observation applications, a solution to fill the digital internet divide. We'll take it's 31, so we'll take a yes.
Perhaps Stefan, you know, at the Copernicus Marine Service, we are organizing at the moment hackathon dedicated to Africa, and WEkEO is the hosting platform for this hackathon. So perhaps in the audience there is participants of the hackathon. They came to have some information on how to use the data and the platform. So welcome to them.
Okay, so 8-minute break. See you at 11:40 CEST. For those who are not on this time zone, let's go and have a coffee or a glass of water. See you in a short while.
Thank you. Bye.
Yes, I think we can kick off the next part of our presentations. And in the meantime, in fact, unfortunately, Aurélien couldn't join us due to technical issues, but I managed to download his video presentation. So we're gonna stick to our agenda, and without further ado, we're gonna dive into more and more detailed overview of the platform as prepared by Aurélien. And I'm gonna share with you all his presentation. And as I've mentioned before, we will right after dive into questions and answers live with all our panelists as well today. So hope you have had a good coffee break as well. Yes, so just gonna share, hopefully it will work now with the video.
Wait a second,
yes?
before
yes?
you launch the video, just a comment
Please.
from my side.
Please, Stefan.
Fabien has shown us how to process data, play with data in the cloud. And that's obviously the main focus and aim of the WEkEO DIAS, but it does also perform the very classical function of being an access point where you can download information, download data. So Aurélien's presentation is using this, let's say, more old-fashioned way, and is showing how you can also download the data and ingest it into an open source GIS. In this particular case, he's using QGIS, just to show that the two, WEkEO enables the two different ways of processing in the cloud, but also who can do more, can do less, obviously. You can also use it to just use QGIS on your desktop or laptop computer. Just this little bit of an introduction. You can launch the video now, Joanna.
Thank you for the clarification and specification, Stefan. Yes, go ahead right now.
Welcome to this QGIS session for the WEkEO Renewable Energy webinar. So first, the question that can raise is, what is QGIS? QGIS is a user-friendly open source geographic information system, and it supports most geospatial vector and raster files types and database formats. So the program offers standard GIS functionality with a variety of mapping features and data editing. QGIS also has supports for plugins that expand its functionality further by providing additional tools. That can be GPS, data support, georeferencing, and additional mapping components. So why is it relevant for renewable energy application? Because it is user-friendly first, because it enables a beginner to quickly display some high-quality geographic data to support an energy policy, for example, or to do a quick impact study on a potential wind farm, for example, or to assess some potential green energy sites. So for the program of this tutorial, first, this is not a scientific tutorial that gives you a method that can be applied for offshore wind turbines application, but this is an example of use of WEkEO datasets with QGIS. The objective is not scientific, clearly. And the use of climate data, we're going to use climate data to assess the mean wind speed in winter to give a first estimation of the winter production for an offshore wind farm. We'll work on offshore wind farms. And then we'll try to use the climate data to assess the mean wind direction to have a first idea of the wind turbine orientation. And then we will try to do a quick assessment of natural event consequences, such as a Eunice storm in February 2022 on an offshore wind farm. So to work on QGIS, we first have to install it. And we're going to do this with a special tutorial. Because we are using a specific plugin in this tutorial, we need to install QGIS in a specific way. So we are going to start by finding the plugin page on the Copernicus Marine Service website. And I think if I just try plugging CMAMS NetCDF, I'm going to find it. Yes, I will. So here you have the tutorial on how to install QGIS, and you have the OSGeo installer here. That is really important. Even if you have QGIS already installed on your computer, you have to do this. So here is the website OSGeo. You install it with this link, and then you will be able to work on QGIS and use the plugin, and that will enable you to use the WEkEO dataset easily. This is an important step because the files that are within the WEkEO datasets are netcdf files, and if you do not use a specific plugin, it can be difficult to cope with this type of dataset. So we are going to open QGIS now because we're ready to begin. So for those who are really not familiar with QGIS, you have to open a new project to start. No, let's open a new project, but I want to I have a quick issue with QGIS. And we're good with a quick restart, sorry about that. Project, new, and I'm gonna save this as a live demo on my GIS WEkEO work environment. Okay, so now that I have QGIS installed in the new project, we have to open and display the continents and the country boundaries to have a background on our map. And for this, we are going to use some WMS flux. WMS is for Web Map Service. It is a standard protocol and developed for serving georeferenced map images. So we are going to find on internet the WMS link there we have to use. So map server demonstration. We're going to use this. It's an open source web mapping. You can have background. So you are going to copy the WMS service link here. And then we are going to add our first layer, that is the background. So layer, add layer, and WMS. So we're going to add some new layer, some new WMS connection that we are going to paste our link here, and we are going to name it map server. And this is all we need to set the WMS connection. So map server connect. And we have what we need here. We have the blue marble that can be a background that is based on satellite images. We have the continents and the country boundaries. So for our use today, we are going to add the continents and to add the country boundaries here. So we have a quick loading time. So we have a country, the continents here. I think we are going to change this a little bit, change the color because we have too many colors here. I'm just going to add a neutral color here, apply. Okay, this should be better. We are going to work on an area that is around Ireland, around here. Okay, so we have our backgrounds here. And then we are going to use some eModeNet datasets before going to WEkEO data. So what is eModeNet? It is a network of organizations supported by the EU Integrated Marine Policy. So I'm going to go to their website, eModeNet. Here it is. So these organizations work together to observe the sea, process the data according to international standards, and make that information freely available. As you can see here, they have different portals where you can find data on bathymetry, biology, chemistry, etc. And they have the Human Activities portal, where we can find some data about renewable energy, as you will see. So I want to access the portal, and we're going to find some data about the wind farms. And the purpose is to do just as we have done with the background, and to use a WMS flux to display the wind farm sites. So we are going to click on download the point dataset information and download options. So we need the WMS link. And here I quickly have to fill in the country and sector. Okay, and then I have the link. So I copy this link and I go back to QGIS. So in QGIS, same thing as before, add layer, WMS layer, and some new WMS connection. Paste here, MODNet human activities. So, okay, and I'm going to connect to this one, and I'm going to search at the end for wind farm points. And I'm going to add it to the map. And here you can see that on our really brand new map, we have the wind farms. So the colors are as following. In gray, we have the planned offshore wind farm. As you know, many projects are under this stage, and that is planned. So we are going to assess some data about these potential sites around the island. So we have our background, and we may now start working on the WEkEO datasets. So first, we're going to use climate data to assess the mean wind speed in winter to give a first estimation of the winter production. So let's go to WEkEO website and search for these data. So, WEkEO. On WEkEO, I'm looking for data. And here you will appear on the viewer. That will enable you to find the data you want. We will work around Ireland, so I'm going to add a layer. So I was talking about some climate data, so we are going to search for climate data. And what we want is some climate data about the wind speed. So I'm going to use this dataset, that is ERA5, monthly average data on single levels from 79 to present. I'm going to add this to map. So there is no preview for this dataset, but don't worry, we can still use it. With the download button, I have to be registered. So I log in. So now I need to set the bounding box from which I want the data. So I have already computed this. So this is -14 for the west, -4 for the east, and 50 for the south, 55 for the north. This is a box around here. You can also use the AOI if you want to download data from another dataset, from for another place. Sorry. So I can here set a bounding box like this. Here, and then I just click on copy AOI from map, and this will be my map. So what I'm interested in is the 10 meter wind speed and the 100 meter U component of wind and 100 meter V component of wind. So wind farm and wind turbines in offshore farms are really high. So we are interested in the 100 meter component of wind, but we don't have the 100 meter component, the 100 meter wind speed. So we will use the 10 meter just to do the exercise. Okay, so these are monthly averaged data. So I want to use the reanalysis one. And I want it from 2000 to 2020. So we'll have a lot of data because we want to work on climate. So we need a lot of data set. We will just focus on January because it will be quick to do this exercise. Otherwise, it would take a long time. So just January. The day doesn't matter because it's monthly averaged, and the time, same thing. we are going to use the netcdf file. I'm going to request this. And so the request has been sent. It will take some time. Here you see request sent successfully. I'm going to monitor it. Here you see all requests, and this one is running. So we're waiting for the request to be completed. And then I click on show results, order. And once the order button has finished, I have the download button. I won't do it because I already have downloaded the dataset. I advise you to rename it because the name won't be super clear. So that's it for the data access. And then we are going to use the netcdf to GIS plugin. So we need first to install it. And we will go back on the page I showed you at the beginning. So plugging CMAMS netcdf here. And you have to download the plugin here. You can download the plugin, download the zip file here. And within QGIS, you have the plugins and manage and install plugins. That will be open. And you have install from the zip file and you search for it. The zip file you have just downloaded and you install it. This is really simple and this won't take a lot of time. So that's it. And once we have our plugin, we have this little Copernicus Marine Service button here. So the plugin has been developed for marine data, but it works for all netcdf files, and you will be able to use it with climate data, for example. So now we're going to use it. So I open it, and here is the plugin. So I'm going to use the plus button to add a netcdf file. So I'm just going to select my import default repository so that it will be easier for the tutorial. Documents, GIS, WEkEO. Okay, so plus data. So I have my ARA5 win for January 2020. So this is what we're going to use. And directly you see that I have the U component for the 100-meter wind and the V component, and I have the wind speed for the 10-meter high. I'm going to start by adding the SI10 layer for all dates to compute the average wind speed at 10 meters for the month of January on the 20 years. So I'm going to say it again, this is not a scientific method, this is just a way to show you what you can do. So I'm going to select all with the shift button, and I'm going to add and close. Okay, great. So here I have all the data for the wind speed at 10 meters. I'm going to just put the boundaries and wind farm, etc. on the background. Okay, sorry about that. Yes, this is better like this. Okay, so here you can see the data, the average wind speed. You see that this is not the same for every January month, considering the color. And you can explore the data like this by selecting the layers. You see here that you have all the years, but the purpose is not to extract a specific year. The purpose is to do an average of these data. So in order to do so, we have to open the raster calculator and compute the average. So raster calculator here. So I'm going to create an on-the-fly raster instead of writing a layer to disk. what I'm going to do is adding these 21 layers and dividing it by 21 just to have the average. So this is something that is not super interesting to do, but it won't take that long. We could also have worked with some Python commands to do this automatically, but as this session is dedicated to beginners, we are just doing this the simplest way possible. So I'm trying while I speak not to forget a year, 2015, 2016, 17. Okay, here we are, and we're going to divide it by 21. So you see that the expression is valid. I'm going to press OK. And I have my new layer that I'm going to extract from the folder here. And I'm going to rename it mean 10 meters wind January 2020. Okay. So here I have my mean average, my averaged data, sorry. I'm gonna tune this a little bit because you see here that is some grayscale, so double click on it and I am on symbology. I will switch the render type to single band pseudo color, and here I'm gonna just reverse it and apply. Yes, I think it's more clear like this. So we have our mean wind January for the whole period, and we will be able to have here the legend to have an idea of the wind speed. So this is around 12 meters per second for the red areas. So once we have our 10 meters mean wind speed, it could be interesting to have the wind direction. So we're going to use, once again, the climate data to assess the wind direction, to have a first idea of the wind turbine orientation. So we will go back to the plugin that is here. And we are going to open the UNV layers. So add layers. I'm going to select the whole layers and add and close. I'm going to do the same for the V components. Okay. So this is the same. I need to put this on the background. Okay, great. I'm going to just remove this one. And you see that I have all my V and U components. I'm going to also compute the mean to try to have the wind direction. And then we will compute a vector from U and V to display the wind direction. So we'll do the same, raster calculator. I'm sorry, this is a bit long, but this is a strong method that cannot be, you cannot find something more efficient than just adding this. So U, I'm going to work on U. Okay, so the expression is valid. I'm going to compute this, and I'm going to rename it mean 100-meter wind direction. No, in January 2000 and 2020. So same here, I'm going to use pseudo color, and I'm going to invert the color ramp just to show you. Okay, so you have the menu. You see that the offshore wind is stronger than the onshore wind, even if it's on the background. I'm going to do the same for V. Press the calculator. Okay, here once again the expression is valid. Okay, I'm gonna rename it. So mean 100-meter wind January. Okay, I'm not gonna change the look of this one because it's not compulsory. I just realized that I haven't specified U and V on each layer. So this is the V layer. So rename. And this is the U layer. Sorry about that. Okay. And I need to fix the layers so that I can use it to compute the vector. So I'm going to export this, save as, and the file name will be mean U. Okay. So we have our mean U fix layer, and for mean V, it will be the same. Okay. So just remove the temporary layers just to keep the fixed one. So to compute the vectors, I'm going to use the toolbox that you can access from here, and I'm going to use the gradient vectors from directional component that I have recently used here, but that is here also. Don't worry about this warning, the method works, no problem. So for the mean U in X component, I choose this one, and for the Y component, let's choose mean V, and I'm just going to compute this. So it may take some time to compute the gradient, but not that much. You will see the layer appearing on the left once it will be done. Okay, so I have gradient here. Great. So you see that the area is clearly on the west dominant wind and coming a little bit from the south. So I can close the toolbox and I will display the gradient. Here. So I will need to change the color to black, and I'm gonna make it a bit wider. Apply. Okay. So in the background, I'm gonna put the mean 10-meter wind with the gradient vectors. I'm going to just put this above. So here we have our first map with the mean 10 meters in the background in red here. So we can first assess the direction and the mean wind speed for January for our wind farm potential site. So this is a first interesting thing to compute. So now we are going to try to work on the marine data. So these maps were more focused on the potential site for a wind farm with the mean speed and the direction, but now we will try to assess the stress under which the structure will be put during an extreme event, for example, and we'll try to assess the consequences of a natural event such as a Eunice storm in February 2022 on an offshore wind farm. So the variable used here will be the wave significant height, and we're going to find it on WEkEO. First, I'm going to just clean a little bit my QGIS project, just so it will be easier then. You can rename the gradient vector here, wind direction. I'm going to remove this so we can start from fresh. So we come back on the data viewer, and we're going to add another layer that is from Copernicus Marine Service. And we are on the European Northwest Shelf Ocean. And we are going to use the waves. I'm going to add, as I was telling you, the sea surface wave significant height. The sea surface wave significant height are from throat to crest of the average from throat to crest of the highest 1/3 of the waves. And we're going to download this variable for February 20 to February 21. And we're going to display this data on the screen with the plugin after. So as before, I'm going to download this. I'm going to put my bounding box that is, okay, so this is loading the metadata, -14, -4 here, 1555. I'm starting to know it by heart. And we're searching for 2022 February from 20 to this same year, 22 of February. And I'm going to request the data, monitor the request. That is successful. No, this is running. Now this is completed, and I'm going to access the result, order, and download. Same here, I have already downloaded the data, so I won't do it again. I advise you to rename it because the name isn't really clear. So once we have done this, we are going to import this layer on QGIS. So we will go back to the netcdf file management. And this time we are going to open the wave analysis and forecast for 20 and 22 February. Here we have our data set. We have the significant height, wave height here, and we're going to open layers. We are going to work on the data from 12 a.m. in the 20th of February here to one day after, let's say 12 also on the 21st. And we're going to add and close. Okay, here we have our data set. So I'm going to put this also under, yeah, so that we have clearly the boundaries and our wind farm potential site that are appearing. So we can have a look at these data sets. So if we uncheck, we will see the storm arriving and the really high wave height coming. Here, we can do it by clicking. And during the night, we'll have the peak. So we can say that the peak is around here, for example. So we'll tune a little bit we'll not tune, but open the symbology. And we have our color ramp here. So starting from blue to red. And if we apply this, okay. So this is a little bit more clear than what was directly imported from the plugin. So I'm going to copy the style, and I'm going to paste this on all the other ones, so that we have something really nice, and the same for every layer. And you see here that the storm is just moving to another place, and we have some really low waves coming. We can display the legend here, so we can see that we were up to nearly 16 meters of mean wave height. So this is a really huge storm here. The reds are here. So our wind farm are exposed to some high waves. And if you are building this, you have to consider the potential harm that a storm can cause to your installation and your wind farm. We are going to now open once again the QGIS plugin. And with this QGIS plugin, I will show you something nice that you can compute directly. And this is good for beginners and to compute also some storm effect. I'm going to remove the group. Okay. And I'm going to take sequence layer that will display us a nice animated image of the storm. So I'm going to select the same time period here, and I'm going to start to display, and you will see here that automatically we will see the storm coming. And this is something nice that is really beginner oriented. Here you have the storm coming. I'm going to put this under so that we will see the potential wind farm. Oh, sorry. I think the sequence is forcing me to have this on top. But you see that the storm is going somewhere else. So to sum up, thanks to WEkEO dataset, QGIS and EMODNet, we've been able to display some climate data about the wind speed and wind major direction with potential wind farm sites in the background. We have also been able to display some structural risk criteria that we have with the wave 8 experienced during the last storm, Eunice. So thanks for watching, and do not hesitate to contact the user support if you have any questions about this tutorial. Thanks.
Okay.
Thank you. Thank you very much to Aurélien Muur for this excellent video tutorial. And I think, Stefan, we can jump into the Q&A right now, if you agree. We're running a bit over time. Apologies for that.
I don't see any questions though in the Q&A.
Exactly.
Maybe
So,
the tutorial is so complete that everybody.
Fabrice, you can unmute your mic, please. Yes.
Yes.
And so I don't see any questions. While you think about any potential questions, I want to remind you that for those who need them, we can issue participation certificates. So don't hesitate to use our functional mailbox and request such certificates, which we will be glad to issue. I don't see any question. Okay, any on the use case and on what was presented, any concluding remarks, Fabrice, that you would want to make?
No, don't hesitate to visit the website, the product catalog, to play with Jupyter Hub once you are registered. And for any question, don't hesitate to contact our user support.
Okay, so before we close, I'm just going to give you a little teaser about future webinars in this second series of WEkEO training webinars. So what do we have? I hope you're seeing my screen. So the sequence of this new series will span from now until the end of June 2022, with a total of 6 webinars. We will be addressing both beginners and experts, although with a number of webinars already performed and delivered, we hope that we have a core of participants that is already knowledgeable about WEkEO. That's the reason why we don't go again through the presentation of the entire product catalog or the features and the various plans, payment plans, etc. The program is 5 thematic webinars. This one being the first one, and one on the new products, because as we regularly add new products, because Copernicus services are evolving and there are new products that obviously are ingested into the catalog. So we're going to present them together with their potential applications. That will be the last one of the series. So here are the next ones. On 28th of April, we'll discuss coastal zone environments. On 19th of May, we'll discuss sustainable tourism applications. On 2nd of June, the Green Deal and how Copernicus can support it through data processed into WEkEO. 16th of June, we'll discuss the intersection between artificial intelligence and Copernicus data, and as earlier said, new products in the WEkEO catalog on 30th of June. One important note, because of logistical reasons, the 28th of April webinar will start 1 hour later than the other ones. So usually all the webinars start at 10:30 Central European time, with the exception of the 28th of April, which will start at 11:30. So we hope that there will be many of you. We hope that this webinar has been of interest. I want to mention also, for those of you who are very much into Jupyter Notebooks, that our colleagues from UMETSAT are organizing a Jupyter Notebook competition that obviously will be based on Jupyter Notebooks, which will be hosted on WEkEO and on datasets that you can, the datasets obviously on the WEkEO. They're pretty easy to find if you go to the UMETSAT website. That's basically it from my side. Just again, thanking the many of you who participated and remained for the entire 2 hours. Again, very happy to have people from not only all over Europe, but also many people from Africa. I saw also quite a lot of colleagues from Egypt. So I want in particular to thank them for participating, because I might tell them a bit late, Ramadan Kareem, and I understand the days are long and the wait for Iftar is long. So we appreciate their time and their being with us today. And as I see there are no questions, I'll just leave Fabrice give the final words as a representative of WEkEO. Thank you again to all of you for attending, to my colleague Anna Maria for organizing, to Aurélien for his tutorial, and to you, Fabrice, for the presentations.
You're welcome, Stefan. Thank you very much, and thank you for your participation, all of you. And this video. You confirm that the video will be accessible. The recording, yeah.
Within about less than a week, it will be available on the YouTube channel. We will obviously put the actual video from Aurélien, so we don't have this issue with the black box, for which I deeply apologize to our viewers. So this will be fixed. For those who didn't get the first part really clearly because of the black box, you'll have an opportunity to have a repeat session on our YouTube channel. So thanks again to all of you for participating, and see you on 28th of April, hopefully, to discuss coastal zones with our colleague Jeff Smith as a lead expert. Thanks.
Thank you very much. Have a nice day. Bye.
Bye.